Hey guys, I'm back again for part 2 of 7.4 lesson. We're going to do example 2 and example 3. I hope you got a kick out of my attire from the first video. I'm going to be asking every other class what they would like to see in the next couple videos. So we are finished up 7.4. Here we go. 7.4, part 2. We're going to approximate square roots. So I want you to have your calculator handy dandy. And also know that these steps, they're a little tricky. And so just take some time if you need to rewatch this video as much as you need, because it is a little tricky until you get the hang of it. Here we go. We are jumping into example 2 because remember, this is the second part of this lesson. Here we go. We're going to estimate. Estimate square root. Estimate. 2 nearest. So A, they want us to do the nearest integer, and B, the 10th. So we're going to have two answers for these problems. The first part is the nearest integer, and as you remember from the last video, integers are positives, negatives, and 0. And B, to the nearest 10th. So A is a little bit more of a basic answer. B is a little bit more of a specific answer. We're getting more details. So think of it as nearest integer as less detail, nearest 10th, more detail. And if I said 100, that's going to be even more detailed than the 10th. Here we go. Estimate, we're going to estimate the square root of 71. So now when we estimate, we're making good guesses, an educated guess. So the first thing you do is you're going to put the square root of 71 in between two perfect squares, which would be the square root of 64. Oh, you know what? Let me give myself some more room here. Square root of 71. So it's in between square root of 64 and the square root of 81. That's the first thing you're going to do. So you're going to put it in between the perfect square that's below it and the perfect square that's above that. And since the first part we want the nearest integer, now we have to figure out how far 71 is from 64 and how far away it is to 81, because this will give us a better idea on if it's closer to this integer or that integer. So let's first take the square root of 64, which is 8. And the square root of 81, 9. So now that we know the square root of 71 is going to be 8 point something, but we want to get close. And we want to get close to the nearest integer, but we don't know if it's closer to 8 or closer to 9. So we're going to figure out the distance. So how far is 64 and 71? So just use your fingers. 64, 65, 66, 67, 68, 69, 70, 71. So it's about, so I'm going to put distance. You could say distance or difference. It doesn't matter. So it's 7 away from 64. And from 71 to 81, hopefully you don't need your fingers on that one. Distance or difference, same thing. It's 10 away. And when you're trying to figure out what integer it's closest to, you're looking for the smallest distance. Because if I put these on a number line, you'd be like 64, 65, 66, 67, 68, 69, on and on and on. And you could tell just by looking at the number line that 71 is actually closer to 8. So for A, estimate the nearest integer, it's going to be 8. Why? Because, wrong side. Because it has the smallest distance to that square root of 64. Which is 8. So square root of 71 is going to be 8 point something. Smallest distance, also known as smallest difference, that's the integer it's going to be closest to. If you're having a hard time with this, what you can do is just write out a number line each time, number them correctly, and then place them, and then you could just see for yourself by counting or just by eyeballing it actually which one's closer. Now, for the 10th, so this is kind of A right here. B, we're still going to use this work. So we want the nearest 10th. So now we're getting kind of nit and gritty. We're getting more details. We know it's going to be 8 point something. But if I just say 8.5, would that be a good place to start? Well, ask yourself, 8.5 tells me that's right smack in the middle between 8 and 9, which would be a number, this number would have to be right in the middle of 64 and 81. But you can see that it's closer to 64 than it is to 81. So that tells you your decimal is actually going to be less than 8.5 because 8.5 would be right smack in the middle. But 71 is not right in the middle between 64 and 81. So where should we start? Well, is 8.1 a good guess? No, because 8.1 would be a really good guess for something like if we had the square root of 65 or 66, something like that. So it's not that far away from being in the middle, but I would start with probably like 8.4. Oops, 8.4. But you want to take a couple of them. So let's go 8.4, 8.5, and let's go 8.3. Okay? Let's see how close we are. And I just started with 8.5 because it was the first one I came up with. And right now I'm estimating to see how close I can get. And so what you want to do is you want to use your awesome calculator for quick checks. And we're going to go 8.3. Whoops, wrong one. 8.3. Hit your x squared key. And you get 68.89. That's not bad. But let's see how close it is when we do 8.4 squared. So 8.4 squared, 70.56. That's not bad either. Now let's do 8.5. 72.25. Well, we can definitely tell that 8.3 is not a good estimate because it's a little bit too far away. And 70.56 and 72.25 are actually closer to 71 than 68.89. That's how I got rid of 8.3. So now what you want to do, if you're trying to figure out if it's 8.4, 8.5, now you have to see how close you are. So 70.56, how close is that to 71? And again, I'm going to think about money. So how close are we to $71? Well, we're only like 44 cents off, which is really, really close. But here, $72 and 25 cents compared to $71, this is $1.25 over. So actually, that is going to be our closest. So our nearest estimate for integer is 8. Our tenth is going to be 8.4. What you want to look for here, guys, you're looking at this number right here. The distance, also known as the difference. You're going to look at these. I erased this. You're going to look at these guys to start on what your decimal is. If these numbers right here, the difference, are very close, they're the same number, or not the same number. If they're 1 away, then I would go something 0.5. But if the distance is like 1, then I would go 0.1. That would be a really good place to start. And this takes a lot of practice, so I'm going to do a couple more. But when you estimate to the nearest tenth, you want to make sure you have your calculator to double check. And the thing is, can you do this whole thing on your calculator? Yes, of course you can. But the thing is, you are going to be estimating a lot the more that you carry on in your math career. And just knowing how to guesstimate a really good decimal is going to be beneficial in many, many classes, and especially when you guys become more of a consumer. You know, when you're buying more things, it's good to be able to make these quick estimates, because well, actually, you can't always pull out a calculator, is what my teachers used to say, but lucky for you guys, you can, because you have phones. So let's go the square root of, I don't like coming up with numbers of my own. Let's go 100. No, that's a perfect square. Oops. It's one of those days. Square root of, what kind of numbers do they have in the book? You know, let's go 111. Why not? Let's go nearest integer. Okay, first step. Put this in between a perfect square that's below it and a perfect square that's above it. So the perfect square below this is 100. And perfect square above that, 125. And now you're going to take the square root of 100, which is 10. Square root of 125. Whoops, I forgot 11. 121, not 125. It is a Monday, you guys. Thank you for being patient. Square root of 121, which is 11. So we now know that the square root of 111 is going to be in between 10 and 11, so it's going to be 10 point something. Now we want to figure out how close it is to the nearest integer. Okay, so now this is where we're going to take the difference, also known as the distance. So I'm going to write difference this time, knowing it's the same thing as what I did last example. Let's do the difference. Same thing as the distance. So how far is 111 from 100? Hopefully you just said 11. And the difference here, how far is 121 from 121? 111, not 121? There's only 10 there. Look how close those differences are. So that tells you when you have to make the closest integer, you are looking for the smallest difference. And 10 is the smallest. So that tells you that square root of 111 is actually closer to a square root of 121. So it's actually closer to the square root of 10. Closer to 10, not the square root of 10. It's closer to 10. Whoops, closer to 11. I was looking at the differences. I should not have picked this number. Sorry. So since this is closer to 11, because it has the smallest difference. Hope I didn't confuse you guys, because I'm using 10s and 11s, and they just happen to be in these two spots. Now let's do the 10th. So we know this is going to be closer to 11, so it's going to be 10 point something somewhere. Now, nearest 10th. Well, since these differences are only 1 away from each other, a good estimate starting point is something 0.5. So let's go. So this is for the 10th. Let's go 10.5. But I want you to try one below that and one above. So I always want you to try 3, and you can use your calculator to try them. So let's go 10.4 and 10.6. Let's just see who's closest. Now, when they're asking you to be which closest, you can go above it or you can go below it. So 10.4 squared is 108.16. Yeah, it's 10.4 squared. And then 10.5 squared is 110.25. Ooh, that's nice. And then 10.6, I bet you it's going to be way over. Yep. This is 112.36. So we want the closest to 111. Well, that one's pretty good, but look, this is getting closer. So this is only 0.75 away, and this is 1.36 over from 111. So that tells you 10.5 is actually your closest. So your nearest 10th is 10.5. So when you estimate the 10th, guys, you want to use the difference here to give a good starting point, I guess you could say, for when you pick decimals. And if you have a really hard time with this, because this is not an easy process, and I know I probably confused you guys here because I was looking at the wrong 10s and 11s when I should have been looking here, but hopefully that was okay. If you have a really hard time with this, then just do all of them. Something 0.1, something 0.2, something 0.3, something 0.4, on and on and on. And then check them on your calculator to help you out. Because it's not an easy process, but it is an important one. And we do need to know how to do this. All right. Like I said, I will have steps. I don't know, actually, did I say this? I don't know. I have steps written out for you guys, and so I will be posting those as well. And let's go. Now we're going to just do some quick comparing numbers. So example 3. Compare, which is greater? Square root of 5 or 2 2/3. When you compare numbers, you want to put them in the same form to make it easier for yourself. Now, do you have to? No, you don't. You can compare numbers any way you want. But for easy's sake, make sure that they're all in the same format. So 2.23. Sorry, not 2.23. It is Monday. 2 2/3 as a decimal is actually 2.6 repeating. And square root of 5. So we're going to use those estimation skills as we did from the previous example. So square root of 5 is in between the square root of 4 and the square root of 9. So we're looking at 2 point something. Well, 5 is only 1 away from 4, but it's 4 away from 9. So that tells you this decimal is going to be closer to 2 point something, meaning the square root of 4. So let's go. Which ones do you want to do? I would actually do 2.1 and 2.2 because it's only one off from square root of 4. So let's go 2.1 squared, which is 4.41, and then 2.2 squared, 4.84. Well, let's go 2.3. Let's see in case we're over. 5.29. Okay, so what this is telling us is we are trying to figure out these guys. We're trying to get as close to 5 as possible. And this is a smidge over square root of 5, which is okay. Because 0.29, it's over, and this one is 0.84, which is under. But which one is closer? This is only 0.16 hundredths away from 5, but this is 0.29 away, which is also 29 hundredths. So that tells you this is actually closest. So our decimals actually be 2.2. And so when you compare these, which one's greater, 2.2 or 2.6 repeating? 2 2/3 is repeating. You can also put these on a number line. But if you want to put them on a number line, you need to make sure that you have the same format, whether it's the decimals or the fractions or square roots or something like that. So on here, what I was trying to do is I was trying to figure out a decimal to get the closest to square root 5 as possible. And that's why I was doing these right here to estimate. Worst comes to worst, you can just put this in your calculator as well. Let's do one more. Let's go square root 10 and negative square root 5. Let's just do these on our calculator. So square root 10, which is really close to the square root of 9. So it's going to be 3 point something. And since it's only 1 away, I'm going to say 3.1 or 3.2. But let's look. What is calculator? I haven't even looked at this. What does that say? Can you see that? I don't know. 3.16. 16, blah, 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 blah. I was pretty good on that. Now, the opposite of the square root of 5. So if it has a sign, your answer has a sign. Now, square root of 5, we just did. It's going to be approximately 2.2. And actually, you know what? Let's do that. What is the square root of 5? Nope, no, I don't want the cube root. Did it again. 2.23, blah, 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 blah. Ooh, we were good on that. So, when you are comparing these, which one's greater? Remember, all positives are always greater than any negative. You don't actually even really have to take the square root of these. If you can remember that any positive is greater than any negative, you're good to go. So the greater one, square root of 10. I think that's good for today. I hope I didn't confuse you guys on the approximating. If you have questions, please send me messages. It's not the easiest thing in the world, so hang in there. Hope you're doing okay, and I'll see you later.